Ask anyone who remembers the 2000 election, and they'll tell you Al Gore claimed he invented the internet. Here's what he actually said. During my time in the United States Congress, I took the initiative in creating the internet. Not invented. He didn't say anything close to it. He said he took the initiative, meaning he pushed legislation, fought for funding, made it a political priority when nobody else in Congress was paying attention.
But language doesn't travel the way it's spoken. It gets compressed, stripped of context, handed to people who weren't in the room, and what travels is almost always the version that fits in a headline.
Within days, the phrase got compressed. Late-night comedians picked it up. Republican opposition researchers circulated it. In the version that stuck, the version most people still remember 26 years later, was Al Gore says he invented the internet. 3 words got clipped out of a longer sentence, and those 3 missing words are the difference between a ridiculous claim and an accurate one.
Vint Cerf and Bob Kahn, the 2 people who designed the foundational protocol of the internet, wrote a joint statement defending Gore. The closest thing the internet has to founding fathers. They said no other elected official had done more to support the development of what became the internet.
Cerf and Kahn called Gore the first political leader to recognize the importance of the internet and to promote and support its development. That's not a political endorsement, that's an engineering assessment from the 2 men who built the thing. The question isn't whether Gore's claim was embarrassing, it's what he actually did, and what that reveals about how the internet got from a military research project to the thing sitting in your pocket right now.
October 29, 1969. A computer at UCLA sends a message to a computer at Stanford Research Institute, about 350 miles away. The message is supposed to be the word login. The system crashes after 2 letters. The first message ever sent across what would become the internet is low. Not exactly a grand announcement.
But the network it traveled across, ARPANET, that's the starting point for everything that follows. ARPANET was funded by the Defense Department's Advanced Research Projects Agency. It wasn't built to survive a nuclear war. It was built to let researchers at different universities share expensive computing resources. In 1969, a mainframe computer could fill a room and cost millions of dollars. Instead of buying every university its own machine, connect the machines that already exist so researchers can use them remotely.
So the original internet wasn't built for communication. It was built to share hardware.
Right. The communication part was almost a side effect. Researchers got on the network to run programs on distant computers, and then they started sending each other messages. Email wasn't part of the original design. It was invented in 1971 by a programmer named Ray Tomlinson, 2 years after ARPANET launched. He needed a symbol to separate a user's name from the machine they were on. He looked at his keyboard and picked @ because it appeared in nobody's name and couldn't cause confusion. He chose it in about 30 seconds. Then he sent the first email to himself from one terminal to another sitting right next to it, and later said he couldn't remember what it said. By 1973, email accounted for 75% of all ARPANET traffic. The network built for researchers to share computers had been quietly taken over by something nobody planned for 2 years after one engineer picked a symbol almost by accident.
Build it for one reason, watch people use it for another. That pattern repeats through the entire history of the internet.
In the early 70s, ARPANET had a problem. It was one network. There were other networks being built at universities, at research labs in other countries, and they couldn't talk to each other. Each one had its own rules, its own protocols, its own way of packaging and routing data. They were islands.
Which is where Cerf and Kahn come in.
In 1974, Vint Cerf and Bob Kahn published a paper describing a new protocol, a set of rules for how different networks could exchange data with each other. This became TCP/IP, Transmission Control Protocol, Internet Protocol, the two-part system that decides how data gets broken into packets, sent across a network, and reassembled on the other end. TCP/IP was a common language. If your network spoke it, it could talk to any other network that spoke it, regardless of what hardware you were running or who built your system. It was an agreement, a standard, and anyone could use it for free.
And that openness was a choice, not an inevitability.
An enormous choice. IBM was building proprietary network protocols at exactly this moment, designed to run on IBM hardware and keep customers inside IBM's ecosystem. AT&T had its own networking ambitions. The default outcome of the 1970s, if you were placing bets, was a fragmented landscape of incompatible corporate networks. Cerf and Kahn made it open instead. That decision, more than any single invention, more than any single piece of hardware, is what made the Internet, because it meant the network could grow without anyone's permission, and it meant decades later that the fight over who controls the Internet would have to be fought at a different layer, not at the protocol level, but at the application level, which is exactly where we are now.
But even with TCP/IP, we're still talking about a network used almost exclusively by researchers, military personnel, and university computer scientists. For a decade after TCP/IP, the Internet is a tool for maybe a few thousand people. What changes that?
Two things. One is technical and one is political. The technical one comes first. January 1st, 1983. ARPANET officially switches over to TCP/IP. This is sometimes called Flag Day, the day every machine on the network had to be speaking the same language or get cut off. After that, TCP/IP becomes the standard. Other networks start adopting it. The network of networks starts growing. But it's still expensive. It's still hard to access. You need institutional backing, a university account, a government contract, a research grant. The average person has no way in and no reason to try. The Internet in 1985 is like having a highway system that only government vehicles can drive on.
And here is where Al Gore's story starts.
Al Gore enters Congress in January 1977 as a representative from Tennessee, not yet 30 years old. His father, Al Gore Sr., was a senator who championed the legislation that built the interstate highway system. This matters because Gore understood from his family's history what large-scale infrastructure investment could do. His father had watched a network of roads transform the American economy. Gore looked at computer networks and saw the same potential. Very early, by the mid-1980s, Gore was pushing for what he called high-speed computing networks. He held hearings, he commissioned reports, he talked to researchers. He was doing this at a time when most members of Congress had never touched a computer, let alone thought about networking policy. This wasn't a popular cause. There was no constituency demanding it. There were no lobbyists for the Internet in 1986 because the Internet, as a public phenomenon, didn't exist yet.
So he's making an investment argument to colleagues who can't see what they're investing in.
Exactly. And the argument he made was a direct echo of the interstate highway system. His father's highways moved goods and people. Gore argued that high-speed networks would move information, and that the economic returns would be just as large. He called it the information superhighway. That phrase gets mocked now, but in context, it was a deliberate analogy designed to help legislators understand something they had no frame of reference for. And vote they did. Gore introduced the High-Performance Computing and Communication Act of 1991. It passed the Senate 79-8 with 13 abstentions. George H.W. Bush signed it into law on December 9, 1991. The bill authorized $600 million in funding for high-performance computing, machines powerful enough to run scientific simulations, model complex systems, and process data at scales ordinary personal computers of the era couldn't approach, and the networks to connect them. One of the programs funded under that bill was the National Center for Supercomputing Applications at the University of Illinois at Urbana-Champaign, NCSA. And NCSA is where a young undergraduate named Marc Andreessen was working. But there's one more piece before we get there, because even with TCP/IP, even with the growing network, the Internet in 1990 is still essentially text-based. You navigate it by typing commands. There are no pages, there are no links, there are no images. If you want to find something, you need to know exactly where it is and how to ask for it. It's a library with no catalog and no signs on the shelves.
Which is the problem Tim Berners-Lee solves.
In 1989, Tim Berners-Lee, a British computer scientist working at CERN, the European Physics Laboratory in Switzerland, writes a proposal. He's trying to solve a practical problem. Researchers at CERN can't easily share documents with each other. His solution is a system built on three inventions: HTML, hypertext markup language, a language for formatting documents so they can be read by any computer; HTTP, hypertext transfer protocol, a set of rules for moving those documents across a network, the same kind of agreed-upon standard that TCP/IP established for data generally, but specifically for web pages; and URLs, Uniform Resource Locators, addresses that tell your computer exactly where on the network a specific document lives, the thing that starts with http://. Three separate problems, three separate solutions, and Berners-Lee tied them together into a single system. He could have built any one of them and stopped. He built all three because he understood that none of them worked without the others. A formatting language without a transfer protocol is a document standard nobody can share. A transfer protocol without an addressing system is a highway without exit signs. All three had to exist simultaneously, or none of them worked. Together, these three things create the World Wide Web, and Berners-Lee makes a decision that echoes what Cerf and Kahn did 15 years earlier. He makes it open. No patents, no licensing fees. Anyone can build on it. The web goes live in 1991.
In the same year, 1991, two things happen with no knowledge of each other. Berners-Lee publishes the web from a physics lab in Switzerland. Gore's bill gets signed in Washington. Neither man is thinking about the other, but the collision of those two events is what opens the Internet to the world.
And those two currents converge at NCSA. Marc Andreessen and a programmer named Eric Bina are working at the supercomputing center that Gore's bill funded, and they start building a piece of software that will take Berners-Lee's World Wide Web and make it visual, make it intuitive, make it something you could hand to a person who had never typed a command in their life. They called it Mosaic, and it launched on April 22, 1993. What made Mosaic different from what came before?
Before Mosaic, web browsers existed. Berners-Lee had built one himself, but they were crude, text-only or close to it. If a page contained an image, you had to open it in a separate application. Difficult to install, designed by researchers for researchers. Andreessen and Bina made images appear directly on the page, in line with text, which sounds like a small thing until you realize that images on a page is the visual grammar of every website that has ever existed since. Mosaic ran on regular personal computers, Windows machines, Macs. It had a graphical interface that looked like other software people already knew how to use. You pointed and clicked, you followed links, you could see pictures where the text was. It sounds almost absurdly simple now,
but in 1993, it was a revelation.
It was the difference between reading a manual and opening a window.
Within months, Mosaic had over 2 million users. Within a year, web traffic had increased by tens of thousands of %. Numbers so large they stopped feeling like statistics and started feeling like a different kind of event entirely. The internet had existed for 24 years. The web had existed for 2. But the moment ordinary people could see it, the moment it had a face, everything accelerated beyond anyone's projections.
Gore's bill funds the center. The center employs Andreessen. Andreessen builds Mosaic. Mosaic opens the web to the public. Gore didn't write a line of code. He didn't design a protocol. He didn't engineer anything.
He wrote the checks. And in the history of technology, writing the checks is not a footnote, it's the hinge. Research happens in labs, but labs need funding. Funding comes from somewhere. In this case, it came from a piece of legislation that one senator spent years pushing through Congress because he believed before almost anyone in politics that networking infrastructure would transform the economy the way highways had. He was right. And then he got turned into a punchline for saying so.
By April 1993, the internet has gone from a crashed 2-letter message between 2 California universities to a network that millions of people are about to discover. And it's open. TCP/IP is open. The web is open. Mosaic is free to download. Nobody owns the experience of being online.
In 1993, the internet is an open system built with public money on open standards. Nobody controls it. Nobody curates it. Nobody profits from the act of connecting to it. And that is about to change, because the same month Mosaic launches, there are people, smart people, ambitious people, people with capital, looking at 2 million users and seeing something Gore's bill never anticipated. Not a public utility, not a research network, a market.
Pulse Deep Dive presents Al Gore Invented the Internet, produced by Singularity Pulse Network. This series is for informational and educational purposes only. Historical accounts are sourced from published research, reporting, and public record. Some timelines are condensed for narrative clarity. Nothing in this series constitutes legal, financial, or technical advice. Views expressed are those of the hosts and do not represent the positions of any organization mentioned.
Origins is a different kind of show. Every Sunday, we investigate the forces that shape the modern world, the geography, the science, the commerce, the decisions made centuries ago that are still playing out today. Find it wherever you listen to this podcast.
I'm Caden. The Pulse Brief is every weekday, 10 minutes. AI, space, crypto, cybersecurity, what matters most today? Find it wherever you listen.